Assalamualaikum warahmatullahi wabarakatuh. Good afternoon everyone, good afternoon ladies and gentlemen, good afternoon the committee of ICMScE 2021. First of all, I would like to read the title of the article that I would like to present to you. The title is Students' Epistemological Obstacle on Analytic Trigonometry. And the authors are me, GITA RAHAYU. I'm a student of Program Studi Pendidikan Matematika S2, Universitas Pendidikan Indonesia. And the second authors is Mr. Rizky Rosjanuardi as a lecturer at Departemen Pendidikan Matematika, Universitas Pendidikan Indonesia. As you know, that trigonometry continues to be an essential component of secondary school curriculum. According to Indonesia Ministerial Regulations number 37, 2018, analytic trigonometry is one of the competency standard components in the mathematics specialist subject in the grade 11 natural science program. This topic is divided into several subtopics, including the sum or difference of two angles, double angles, trigonometric multiplications, trigonometric sum and difference, and specific form of analytic trigonometry. High school students perceive analytic trigonometry as a complex and abstract subject. Trigonometry is frequently used to explain divine new ideas and concepts mathematically. Learning trigonometry analytics, students use algebraic techniques, geometry realities, and trigonometric relationships to derive results from arithmetic and geometry. Essentially, the process development of the knowledge, an individual often encounters obstacles. Learning obstacles is a constraint faced by students during learning due to learning that isn't optimal. Learning obstacles distinguish to three types. First is ontogenic obstacles, didactical obstacles, and epistemological obstacles. In this article, I analyze the epistemological obstacle. What is epistemological obstacle? Epistemological obstacle is essentially person's knowledge that is limited to a particular context. Epistemological is one of the challenges the teacher faces while teaching mathematics. If students are presented with different contexts, it's much challenging for them to solve. The obstacles to acquiring this new knowledge frequently arise due to students' inadequate comprehension or knowledge of the particular context. One indication that arises from this obstacle is when students have difficulty applying concept or knowledge in different contexts they didn't find at the time of learning. Don't you know that trigonometry is not easily topic that students could understand? Several previous studies had found that students experience learning obstacle while studying analytic trigonometry. When students involve trigonometry, students encounter epistemological obstacles in difficulties utilizing the cosine formula for the number and difference of two angles with a positive angle size. This obstacle causes students to find it challenging to change the angle size into negative form. The learning obstacle in analytic trigonometry material is that students are unable to correctly use trigonometry formula such as manipulating angles into number or different particular angles, and students are unable to relate problem solving to trigonometric formula of the number and difference angle. Meanwhile, students must connect numerics, manipulated symbols, and apply their trigonometric function to understand and solve analytic trigonometry material problems. So, the aim of the study is finding expect to identify epistemological obstacles in analytic trigonometry. The authors use didactical design research or DDR that employs an interpretive paradigm. Participants were 14 students from a high school in Kuningan who had a prior knowledge of analytic trigonometry. They were namely S1, S2 until S14. In data collection, the authors used a respondent ability test and in-depth interviews. How is the data collected? First, students completed the respondent ability test, which consists of 5 essays about the analytic trigonometry. The researcher observed the students' response, then selected several students for in-depth interview. The writer conducted in-depth interview to learn more about the student's understanding of analytic trigonometry and identify the epistemological obstacle. How is the data analyzed? First, identifies the learning obstacle on analytic trigonometry based on the respondent ability test and in-depth interview. Secondly, summarize students' answer based on the difficulties that arise. Then, select the main points by sampling students on various difficulties. Then, the authors present into the form of narrative text and image also connects the answer and the result of the interviews by presenting the data. Then, the authors conclude the findings are expected to be clarified as conclusion. So this is the result and discussion. As you can see in the PowerPoint, this is the problem 1, and then the goal of the problem 1 was to determine students' understanding of the scene of the difference between two angles. And as you can see, he answered the scene 15 degrees to scene 60 degrees subtracted by scene 45 degrees, which is this is wrong. And then as you can see that his response is mean that he didn't understand how to calculate the scene value of an angle obtained by subtracting two spatial angles. These findings imply that knowing the first step in answering the question doesn't guarantee that the formula is used correctly, resulting in students not answering them correctly. And this is the problem 2. Student asked to find the trigonometric summation result below, and the goals of the problem 2 is same as the problem 1. It is assess students' understanding of the cosine of the difference between two angles. She defined as spatial angles because she assumed that the non-spatial angles it couldn't using the formula directly. So this is her answer, and student 2 only knew the formula but didn't understand its application. This finding suggests that the student only know formulas and didn't build a reasoning from the formulas they obtain or understand how formulas are constructed and resulting in meaningless concept. This is the problem 3. The first one, student 3 were giving the correct answer, but he didn't give the evidence, the correct evidence, but he didn't mention how to outline the point 1. And as you can see that as 3 were giving the correct answer to a question doesn't always imply conceptual or perceptual understanding of the written materials. Proofs are not easy for the learner. And then the second answer, he said it's same because it's a multiplication. We just can multiply and let it into the bracket. As you know that as for response is illustrated that the student has misconception. Students' misconceptions were indicated since he didn't understand the concept of analytic trigonometry, and these findings suggest that students who had prior knowledge, prior learning experience doesn't always understand what they are learning. This is problem 5, and students asked to simplify the multiplication form below, and the aim or the goals of these questions is to assess students' understanding of trigonometric multiplications. And the problem are posed in various ways of trigonometric multiplication. As you can see, here students is outline this expression to addition and subtractions of trigonometry, but it isn't the correct ways to solve this problem. When the authors interviewed the student, he said that the form of the multiplications in this task is different from the usual multiplications that he studied in the class. It happened because the intensity of using trigonometric multiplications in the class is relatively rare. This is students' inability in educate because the students only remembers at that moment without understanding what he is learning in that time. So let me conclude these presentations.